Hello friends, we now start with a new chapter in chemistry, that is the second part of the study of compounds. The compound we are studying today is ammonia. Okay, so that is the chapter ammonia. We are using the textbook Viraf Dalal. So first of all, introduction. Ammonia was initially called alkaline air. Okay, so the name initially given to ammonia was alkaline air. It was in 1774 Joseph Priestley first prepared ammonia by heating a slag lime with sal ammoniac, and he called the gas as alkaline air since it was found to be basic in nature. So because the gas he found was basic in nature, we know that alkalis were present at that time, so he named this particular gas as alkaline gas because all other alkalis or bases are normally solids. So this is the one which is a gas, so that's why it was a bit different. See, normally all the we have studied in acid base and salts that the bases were the oxides or hydroxides of metals, and the only exception over here is ammonia. So ammonium hydroxide is the only non-metallic hydroxide which is basic in nature. So that's why we are studying this particular chapter in detail. In 1785, Claude Berthelot studied the chemical composition of the gas. In 1800, Davy further established its basic composition and proved ammonia to be a compound formed from the elements nitrogen and hydrogen. So it was in 1800 that Davy found that it was a combination of nitrogen and hydrogen. Till that time, they had considered it to be just a particular chemical composition, and so that was the discovery. We now come to the occurrence. Ammonia occurs in free and chemically combined state, so it is present in both the states as well as the free state. Ammonia is present many places, and it is also in a combined state. So in free state, a small quantity of ammonia occur in the atmospheric air and natural water. Ammonia is also produced when nitrogenous matter decays in the absence of air, putrefying bacteria on organic matter in the soil, and the ammonifying bacteria on the nitrogenous organic matter. For example, urine bring about the decomposition. So that's right. So all the nitrogenous wastes, okay, whatever is a nitrogenous waste which is going to be given out any place, whether it's a bacterial thing or whether it's a human urine, all these contain ammonia in free state. So that is why the सुलभ शौचालय के बाहर जो smell आता है, that pungent smell what you when you get when you are passing a public toilet, and that is nothing but the smell of ammonia. In combined state, ammonium salts and ammoniacal liquor obtained on destructive distillation of coal are two important sources of ammonia. So ammonia is also present in a combined state in ammonial salts and ammoniacal liquor. So that is the combined state. Now we come to the main part of the chapter, and that is laboratory preparation of ammonia. So for the laboratory preparation, the preparation of ammonia is carried out by heating a mixture of ammonium salt, that is NH4Cl, with an alkali CaOH twice. So we can take any ammonium salt, it could be a sulfate, it could be a chloride. So it is not necessary that it should be only sulfate, as we are given chloride which is given over here. You can also have a sulfate, ammonium sulfate, that's also not a problem. So the reactants or the equation what we are talking about is, we are seeing the second equation which is given in the textbook. So first, the second one is NH4 twice SO4 plus CaOH twice. So that is what they are taken. They have taken ammoniacal salt, that is, okay, we take the third last equation, okay, we take the fourth equation because that is what exactly they have taken. So we take over here NH4Cl, right, we take NH4Cl and CaOH twice, and on reaction it becomes CaCl2 plus NH3, it will be H2O plus NH3. So that will be the resultant thing with the gases coming out over here in this form. So this is the reaction with the balancing coming here as 2, here as 2, and here as 2. Yeah. Okay. So this is the equation. 2NH4Cl plus CaOH twice, 2NH4Cl plus CaOH twice, giving me double displacement के हिसाब से भी, और it will be so CaCl2, CaCl2, and it is going to be water plus ammonia. So this is the reaction which is going to be taking place in the laboratory preparation. Apart from that, you can use here NH4SO4 and here NaOH, giving you Na over here. It will be giving you NaCl plus H2O plus NH3. Or if you take NaSO4, then it will be NaOH, that will be Na2SO4 and H2O plus NH3. So in any case, you are going to get one salt which will be based on the alkali what you have taken, and the water and ammonia will be a part and parcel, because ammonium salt is the must. Whether you are taking a sulfate or a chloride is not a problem. So we see that. Now let's see the drawing of this particular thing. So the diagram goes this way. That is this flask. Flask is slightly tilted position. So mark this particular thing, that this tilted position is for a particular reason. So yeah, there is a particular reason for this tilted position, and you are going to have this both these compounds combined together and placed over here. So here it is NH4Cl plus CaOH twice. So this is what is there in this particular thing, and of course you are going to place it in and going to heat this over here. So this heating will be required, and then what is going to be there is there will be a plunger, and then there is going to be the delivery tube. Now as usual, the delivery tube will be passing through a drying agent. So there will be a desiccator at the bottom. So we are going to have a drying agent or a desiccator. You can have any of them. So you will be having a thing like this, wherein there will be a passage through which there will be a drying agent in between, and then you are going to collect the gas oil. So this is the drying agent. So this is all the drying agent. So the drying agent over here is CaO. So CaO drying agent. CaO is a drying agent, and you can see that the collection will be in a glass gas jar, which will be inverted like this. So the air is going to come out, and so accordingly NH3 will be here, and this is done by downward displacement of air. So this is what we are talking about. The downward displacement of air will be the collection method. So here we see that, so what exactly happens, it's a simple reaction that these two things are in this particular flask in a tilted position. You are heating this thing. On heating, the bubbles are going to come out. The bubbles are going to come here, enter into this particular place, and so they are going to enter into this particular delivery tube, and this delivery tube is made to pass over here in a chamber which contains the drying agent. So this is the drying agent. So because water is already a part and parcel of the reaction, so that's why water vapor will be there. So this water vapor needs to be taken out from that particular mixture of ammonia and water. So accordingly, the water is going to absorb here, and what we'll be getting over here will NH3. Now because ammonia is lighter than air, that's why air is going to go down and ammonia is going to go upwards. That's why ammonia goes upwards and represses the air downwards. Hence we give the collection method as downward displacement of air. So let's see in detail about the laboratory preparation now, and why we have kept it tilted and things like that. So let's see one by one. First of all, is yes, you can use ammonium sulfate with sodium hydroxide, or ammonium sulfate with calcium hydroxide, or ammonium chloride with sodium hydroxide, or ammonium chloride with calcium hydroxide. The result will be a salt plus water plus ammonia. So the result will be salt. This will be the salt. This will be water, and finally ammonia. So this is what we are going to get on the reaction of the two things. You are going to take an ammonium salt, and plus a base. So this is a base which we'll be taking. So ammonium salt and alkali, yeah, we'll write it as alkali because you want it to be soluble in water. So it will be an alkali. Now the above reaction of ammonium salts with alkali distinguish them from other salts, since salts other than ammonium salts will not react with alkalis on heating to liberate ammonia. So of course, if I use any other kind of a salt over here, ammonium salt ke siva, they're not going to give me ammonia. So yes, definitely I cannot use any other salt. The above ammonium salt are white solids soluble in water, liberates pungent smelling ammonia gas on heating with alkalis like NaOH and CaOH twice. So we are using an ammonium salt, and the end result will be that in the end of the reaction, you will be able to smell a pungent smell of ammonia coming out from the reaction. So that is what is the observation, what you can see. Now talking about the reactants, ammonium chloride and calcium hydroxide slake lime is taken in a round bottom flask. Okay, so it is a round bottom flask in which you are taking ammonium chloride and calcium hydroxide, that is slake lime. Products, what you are going to get will be calcium chloride, water and ammonia. Procedure: the reactants ammonium chloride and calcium hydroxide are ground together and heated slowly in a round bottom flask with its neck sloping downwards. Observation: the ammonia gas obtained in the flask passes through the delivery tube in drying tower and is collected in an inverted glass jar, so gas jar. So that's what you can see, that at the end you are allowing it to pass through a drying agent and getting the resultant gas in the gas jar, which is inverted in nature. Drying agent used will be quicklime, CaO will be quicklime, which will be there in the drying tower. Precautions. Now this is important. The reactant should be in finely powdered form to initiate maximum surface area, and the slake lime used should be in a higher ratio. Okay. Now why it will be in a higher ratio, we'll just take it in a bit later. So what is required is that the slake lime should be in a higher ratio over here. The round bottom flask is kept inclined, so and next, very important, is ammonium nitrate is not used in the reaction because ammonium nitrate is an explosive material. So because it is explosive and it decomposes, that's why it is dangerous to use it. So, and plus it decomposes also, so it will just get decomposed, and that is the reason we are not using nitrate. Okay, ammonium nitrate is not taken as a salt for the experiment. Remember this thing, ammonium nitrate cannot be taken as the salt to do this reaction. You will need to use only chloride or sulfate. Collection: ammonia gas is collected by the downward displacement of air. It is lighter than air, and it is soluble in water, hence not collected over water. So same as what we see in HCl. Ammonia also is highly soluble in water. In fact, it is much more soluble in water than HCl gas. HCl gas of 452 volumes, this is more than 700 volumes. So that's why we cannot use water over here. And ammonia does not get mixed with air. It is not going to combine with air to give you something else. So that's the reason it is remaining intact in air, and hence air can be given out. And it is by the downward displacement of air because it is lighter than air. So the collection method is going to be downward displacement of air because it is lighter than air, and secondly, it cannot be collected over water because it is highly soluble in water. Identification. Now identification is very simple. In HCl, what will you do? Yes, we took the ammonia liquid, glass rod dipped in ammonia and placed it over there to give you dense white fumes. Here, instead of, because we are getting ammonia, we will take HCl. Okay, we are going to take HCl in a glass rod and place it over here. And when it is going to give me dense white fumes, I understand that this glass jar is completely filled with ammonia. So that's why the main thing over here will be that ammonia is going to be available to the glass jar is filled with ammonia or not will be identified by placing a glass rod dipped in HCl and brought near the jar. If the jar is full, dense white fumes of ammonium chloride are going to be formed. Now let's see in detail about the reactants, and which could be a good give reason questions also. So let's see one by one. Dry ammonium chloride and slaked lime are thoroughly mixed and heated gently in the laboratory preparation of ammonia. Okay, so that's very clear. You are taking a fine powder of this and this, mixing them together and put it inside over here. Mixed with, so dry ammonia gas and slaked lime are going to be there together. Now we see here that a higher ratio of by weight of alkali used. Right? We will see that you are going to use a higher ratio of alkali because that is to make counteract the loss of sublimation of ammonium chloride on heating in solid state. See, in solid state, when you are going to heat it, it is going to form into gases because ammonium chloride is one which is going to be sublimation. Okay, it goes under sublimation. So ammonium chloride on heating will not form into liquid, but it will form into gases. So because of that, there will be a good quantity of ammonium chloride around here because of the formation of gas. See, liquid hota to udhar. So to overcome that thing, so that's why we are taking more quantity of CaOH twice, so that the may counteract the loss of sublimation of ammonium chloride on the heating in the solid state. So that is why we are taking the alkali. So the alkali what we are taking over here will be of a higher ratio by weight than this one, so that whatever decomposition takes place or sublimation takes place of this is counterbalanced by the excess amount of CaOH present over there. Calcium hydroxide is used since it is now we have got NaOH also possible, CaOH also possible. So why we are still using CaOH twice? Since it is cheap and unlike other caustic alkali is not deliquescent. So yeah, it is not deliquescent, and that is why it is not going to absorb the moisture. Accordingly, we see that we are using CaOH twice. Ammonium nitrate is not used. Explosive. Yes, so ammonium nitrate is not used in the laboratory preparation since it is explosive in nature and may itself decompose, forming nitrous oxide and water vapor. All ammonium salts in general heated with alkali liberates ammonia. So yes, they all liberate ammonia, but we are not using nitrate because it is explosive and it decomposes. So because we don't want it to decompose and we don't want any kind of a dangerous explosive thing to take place, that's why we are not using ammonium nitrate. And the last thing is, yes, why this inclined position? Okay, so round bottom flask is kept in an inclined position. The reactant being solid are ground together thoroughly to provide maximum surface area for reaction and heated in the round bottom flask kept in the inclined position so that water vapor formed may not trickle back and crack the hot apparatus. So what they are expecting is this way, that when this is heated, there is water vapor which is generated over here. So this water vapor, if this would have been straight like this, what will happen? The water vapor will come over here, it will condense and condense करके वो trickle down यहाँ पे होगा, right? अगर वो यहाँ पे trickle down होगा तो यहाँ पे heat is there. So when it is trickling down, it will suddenly cool this area and there would be the possibility that it would crack. Hence what they do is that they inclined it so that water vapor, whatever is there, it will trickle down in such a way that it is entering inside over here and there would be water formation over here, which is not the heated part. Okay, so we are trying to see to it that on keeping it inclined, water vapor which is there, which is going to drag this way. So that is how we are preventing the trickling of the water vapor into the flask and hence avoiding the cracking the flask. Now, drying of the gas. The ammonia gas is passed through drying tower before collection of the gas. The drying agent used is drying ammonia gas is quicklime, that is CaO. CaO is quicklime, which is used over here. Reason being, quicklime being basic in nature does not react with another base. Quicklime is basic in nature, so it will not react with another basic ammonia gas. So ammonia gas ke sath mein it will not react, and accordingly we are using CaO as the drying agent. We are not able to use a drying agent like concentrated sulfuric acid, phosphorus pentoxide and calcium chloride since they react chemically with the ammonia gas. So since they are going to react chemically with the ammonia gas, we are not using concentrated sulfuric acid, which we know is a very good drying agent, nor phosphorus pentoxide, nor calcium chloride, because all these three, they are given the reactions over here that with concentrated sulfuric acid it will form ammonium sulfate, with phosphoric acid it will form ammonium phosphate, and with chloride it is going to give an addition reaction of ammonia with calcium chloride. So that is why we are not using these compounds as a drying agent. Collection method. Dry ammonia is collected on the downward displacement of air. Ammonia is collected by the downward displacement of air since it is lighter than air. Vapor density is only 8.5 as compared to 14.4 of air. Ammonia is not collected in water because since it is highly soluble, 1 volume of water dissolves 702. I told you it is more than 700, so it's 702 volumes at 20 degrees Celsius and 1 atmospheric pressure. So we can see that accordingly we are not using the downward displacement of any displacement of water. We are collecting it in air. Apart from this particular kind of the laboratory preparation, we can have one more kind of laboratory preparation for ammonia. The next laboratory preparation goes this way. So in the next method, what you are having is you are going to take a nitride. Okay, you are going to take the, it will be this way that the formation of nitride is going to take place. So first you are going to take a metal and you are going to burn it with nitrogen to give you the nitride. So that is one part. But later on, the main thing for us is, the important part is that you are going to take a metal nitride, and with the metal nitride you are going to use just water. So metal nitride plus water is going to give you the result as metal oxide, metal hydroxide plus ammonia. So the reaction could be this way. You have got over here like ALN plus H2O will give you AlOH thrice plus NH3. So this is the reaction which is going to take place when you are using this method. So here it is a simple method. What you are having is, yeah, you will be having a round bottom flask, and that flask will be having two inlets. One will be the inlet for this is funnel, and so this is funnel over here, and then there will be a delivery tube. This is a funnel as usual. As in the HCl case, we are going to dip it inside the water. The here is ALN, that is aluminum nitride, and you are going to, we can take magnesium nitride also. So Mg2N3, that is Mg3N2, sorry, Mg3N2, and plus water. So this is what you are going to have in this thing, and you are going to have the resultant will be that you are going to place it. Now this is the same, the next part is the same as what we had earlier. So we have this same thing. We have the cooling, the drying agent. So the drying agent is over here, and this delivery tube enters inside this chamber, and that you are collecting the gas by the NH3 over here with air coming out. So this is the same thing. This is the drying agent CaO. Everything remains the same. Here only thing is that you don't need to heat this thing. This is the exothermic reaction. So it is going to give you. So by reaction of warm water, metal nitride react with warm water to liberate ammonia. So this is what you are doing. You are going to take some warm water. So we have got magnesium nitride plus water giving you MgO2 plus NH3. Calcium nitride plus water will give you calcium hydroxide plus NH3, and aluminum nitrate nitride plus water, giving you ammonia, aluminum hydroxide plus ammonia. Burning metal, for example, MgCaAl, when burnt in nitrogen gas, forms the respective metal nitrates, magnesium nitride, calcium nitride, and aluminum nitride as the products. When warm water is added to the products formed, that is the respective metal nitrates, the metal nitrates undergo hydrolysis and are decomposed by warm water to give pungent ammonia gas. The corresponding insoluble metal hydroxide is precipitated out. So all these are precipitates, and what you are going to get will be metallic hydroxide plus ammonia. Okay. Now reactants. Sorry. Metal nitride Mg3N2 and warm water. Procedure: the reactant magnesium nitride is placed in a dry flask and warm water is allowed to trickle down into the tap through a funnel. Observation: the ammonia gas obtained in the flask passes through the delivery tube in the drying tower and is collected in an inverted gas jar. Drying agent: quicklime, that is CaO, in the drying tower. Precautions: the lower end of the thistle funnel should be dipped below the warm water in the flask. Since nitrides are expensive, the method is seldom used. So we don't normally use this method because these nitrides are expensive, much expensive than the ammonium salts which we used earlier. So here we are not using much, but yes, you need to keep it down inside over here. So that is the precaution you have to take. Otherwise, ammonia gas will be coming out from here itself. You will not be able to collect it. Collection: the ammonia is collected by the downward displacement of air. It is lighter than air and is highly soluble in water since not collected over water. And identification wise, here the same thing. You are going to take a glass rod dipped in with HCl and place it over here. So glass rod dipped in concentrated HCl acid is brought near the mouth of the jar. The jar is full, dense. When the jar is full, the dense white fumes of ammonium chloride are formed. So this is how you are going to get ammonia in a laboratory by this process. So there are two processes. One was the ammonium salt reacting with a base or alkali to give you the salt plus water plus ammonia, and the second reaction is when a metal nitride like aluminum, magnesium and calcium. So metal nitride are formed by the heating of the metal in nitrogen. That will give the metal nitrides. So this metal nitride, when they react with warm water, they are going to give you metallic hydroxide, and which will be a precipitate because they are insoluble hydroxides. So a precipitate is going to be formed over here inside, and ammonia gas is going to be collected by the downward displacement of air after passing through the drying chamber. So that was about the laboratory process. We'll stop for this video and continue with the Haber's process, that is the manufacturing process of ammonia, in the next video.